The Concrete Technology Division has been in existence since 1948 and has grown into a full-fledged division with specializations in the field of concrete technology, and special focus has been given to repair and rehabilitation of hydraulic structures. Now Concrete Technology Division rechristened to Dam Rehabilitation Center, an integrated approach of investigations, analysis and rehabilitation helps to keep the aging and distressed dams in good condition for better sustainable availability of water. In view of this, CWPRS has established a unique facility of one single point solution in the form of Dam Rehabilitation Center, which houses the entire infrastructure of rehabilitation activities of Concrete Technology Division. This building has been inaugurated by Shri C.R. Patil, Honorable Union Minister of Jal Shakti, in June 2025. The new CT laboratory building at measuring about 15,000 square feet area was essential to accommodate machines and equipment procured under Capacity Building or CWPRS to meet the present-day challenges in rehabilitation and strengthening of distressed hydraulic structures such as gravity dams, powerhouses, aqueducts, barrages etc., as well as to accommodate research personnel. Following studies are being carried out in the new building due to the installation of machines and equipment pertaining to rehabilitation of hydraulic structures, grouting and shotcreting of dams for controlling seepage. Testing of epoxy systems for assessing their suitability for repairs to the hydraulic structures. Identification of suitable repair materials for strengthening rehabilitation of major hydraulic structures like dams, aqueducts, powerhouse, stilling basin and conservation of monumental structures. Developing repair methodology and providing guidance for rehabilitation, strengthening of structures. Assessing quality of concrete and masonry of structure. Evaluation concrete making materials for assessing its suitability. Design of concrete mixes. Testing of concrete for evaluation of its strength, elastic and creep properties and thermal properties.
At CWPRS by developing the facilities for evaluation of temperature rise due to heat of hydration of cement and evaluation of diffusivity of concrete. Simultaneously, capability was developed to use these data to predict evaluation of temperature stresses taking due to account of sustained stresses and creep of concrete. 1500-ton CTM. The digital automatic computer-controlled compression testing machine, 500T, 5000 kN, capacity is required for testing of concrete, masonry and repair materials of various large sample sizes under compression mode. The creep test rigs for concrete is required for determining the specific creep of mass concrete specimens required for evaluation of its tensile strain capacity in laboratory. Tensile strain capacity of concrete mix is essential in estimating placement temperature of mass concrete, which is an important parameter for controlling thermal cracks in mass concrete to be used during construction of hydraulic structures. 5. Constant temperature water bath. The constant temperature water bath is required to evaluate the coefficient of thermal expansion of mass concrete samples of 300 mm dia x 600 mm height cylindrical specimens. It is one of the important thermal parameter required to calculate the thermal stress, which is further used in determining the placement temperature, lift height and lift interval for placing mass concrete in gravity and RCC dams. 6. Thermal diffusivity. Diffusivity is an index of the facility with which concrete diffuses heat in all direction. The equipment consists of hot water bath, in which water is heated through immersed heater. Cured concrete specimen is placed in the water bath at room temperature. The water in the bath is then heated to a certain temperature so that concrete sample is heated up sufficiently without cracking. The specimen is allowed to saturate in the hot water. After achieving saturation, hot water is flushed out and cold water is let in. The temperature in the interior of specimen is recorded at every 5 minutes interval up to a period of 1 hour. From this data, cooling history of the concrete specimen is obtained. 7. Adiabatic calorimeter. For measurement of ultimate temperature rise, adiabatic calorimeter is used. 1 cubic feet of freshly mixed design mixed concrete sample sealed in a polythene bag has been kept in a plastic container and sealed in an properly insulating wooden box known as a diabatic calorimeter, to arrest escape of the moisture as well as transfer of heat for simulating adiabatic conditions. The temperature of the concrete mix and the chamber are measured by highly sensitive platinum-resistant temperature detector. To achieve the adiabatic condition, the temperature of the chamber is so adjusted that difference between the specimen temperature and chamber temperature at any time does not exceed 0.5 OC. Under adiabatic conditions, the temperature rise in the concrete mix sample is monitored and recorded for a period of 7 days. The rise in temperature of concrete is plotted against time in hours. 9 core drilling machine. This portable core drilling machine is required for drilling and extracting cores of 300 mm, 150 mm, 102 mm, and 52 mm dia.
आपण